Hi. In this video, we're going to look at finding the average rate of change of a function. And to start out, we're going to do that from a graph. And then after we've done a couple of those, we're going to do it from a just given the function as an equation. So let's look at this. The average rate of change from x equals a to x equals b is the slope of the line connecting those 2 points with x coordinates of a and b. Now, another way that they could word this is, instead of saying from A to B, they could say the average rate of change on the interval AB. And that would mean the exact same thing. So all it is, it's the slope of the line connecting those 2 points. So in this example here, let's find the average rate of change from x equals 0 to x equals 2. Well, that's going to be from here at x equals 0 to x equals 2. So what I want is the slope of the line that goes through these 2 points. Let me draw that line in. That's pretty good. All right, so the slope of that line is, it's the change in y over the change in x, or the rise over run, or this is actually a mistake here. I need to edit this. It's f of a minus f of b over a minus b. Or you could also do f of b minus f of a over b minus a. Either one of those is fine, but you want to make sure that whichever coordinate you have first on top is also first on bottom. So this was a typo here. All right, so find the average rate of change from x equals 0 to x equals 2. Well, that's going to be f of 2 minus f of 0 over 2 minus 0. So I'm going to come up here on my graph. F of 2 is, it looks like I'm going to have to estimate that, because this point here has an x coordinate of 2, and its y coordinate looks like it's, let's see, each one of those little lines is a quarter. So let's say 2.3. Because it looks like it's a little bit bigger than 2 1/4. F of 0 comes from this point. X is 0, y is also 0. So I just get 2.3 over 2, or 1.15. So that's the slope of that line, and it's also the average rate of change from 0 to 2. Let's do another example. Here's a graph, and I want to find a couple of average rates of change here. If we go from 0 to 5, that's from here to here. And we can look at this graph and tell that the slope of the line between those 2 points is 0. But suppose, well, let's fill the formula in just for instructive purposes. What we would have would be f of 5 minus f of 0 over 5 minus 0. Well, the thing is, f of 5, that's the y-coordinate here, is 0. F of 0 is also 0. So we just get 0 there for the slope of that line. Now to find the average rate of change from 2 to 10, I'll do that one in, I'll do it in dark green. That's the, from here to, oh wait, no. X equals 2 to 10. So if I come over here to 2, let me erase this. So 2, that's right here, and then 10 is here. So again, I'm going to have to kind of eyeball this a little bit. F of 2 is, let's see, let's call that 1.8. That's a pretty good estimate of what that point is, its y-coordinate. And f of 10 is, we can look at the graph and see f of 10 is 5. So the average rate of change here is f of 10 minus f of 2 over 10 minus 2. So that's 5 minus 1.8 over 10 minus 2. So 5 minus 1.8, that's 3.2. 10 minus 2 is 8. I was grabbing for my calculator here, but I don't need that. 3.2 divided by 8 is, well, 32 divided by 8 is 4, so this is 0.4. So 0.4 is the average rate of change, and it's also the slope of this line. All right. Now, after doing those examples, doing a rate of change where you're only given the function is not a big stretch. We just have to, instead of getting our function value from a graph, we've got to get it from plugging in a number. So on this one, the average rate of change of this function from -1 to 5, that's going to be f of 5 minus f of -1 over 5 minus -1. All right, f of 5, I'm just going to do that up here. That's going to be 5 squared plus 2 times 5. So that's going to be 35. F of -1, if I plug in -1, I'll get -1 squared is +1 minus 2. So 1 minus 2 is -1. Hey, this works out nicely. We wind up with 36 over 6. And so the answer here is just 6. All right, one more. Find the average rate of change of this function on 4 to 25. Well, that's going to be g of 25 minus g of 4 over 25 minus 4. G of x is just the square root of x, so this is square root of 25 minus square root of 4 over 25 minus 4. So 5 minus 2 is 3. 25 minus 4 is 21. And we can reduce that to 1/7. So that's all there is to it. Now, we can make these a little more difficult by changing this to something other than just two numbers. So here's an example of that. Find the average rate of change of this thing on 4 to b. Now, in theory, it's no different than the other. You just do f of b minus f of 4 over b minus 4. The difference is f of b is b squared plus b. So we wind up having variables in our answer. So you get b squared plus b minus 4 over b minus 4. And on this one, I would want to look at it and see if I could factor it and cancel something. Turns out on this one you can't factor it. There's no way to factor the b squared plus b minus 4. So we just got to leave that as it is. Let's look at this one. Find the average rate of change of f of x equals 1 over x plus 3 on this interval. All right, so that's going to be f of 1 plus h minus f of 1 over 1 plus h minus 1. All right, the top of this is more complicated than the bottom. The bottom is just 1 plus h minus 1, so that just leaves us with h. On top, though, 1 over 1 plus h. I'm just going to replace the x here with 1 plus h. So I get 1 over 1 plus h plus 3. And then f of 1 is 1 over 1 plus 3. So what I've got here is 1 over h plus 4 minus 1 over 4 over h. Now, I need to simplify this. So what I'm going to do is multiply the top by, well, I'm not going to I want to get a common denominator for those two fractions up there. So let's move this out a little bit. What I'm going to do is multiply this one by 1/4, or not 1/4, by 4/4. You can't just go multiplying it by 1/4, that would change things, but 4/4 is 1. I'm going to multiply this one by h plus 4 over h plus 4. And when I do that, I get 4 over h plus 4 minus h plus 4 over h over 4 times h plus 4. I'm missing a 4 back here. Let's go put it back in. And all that's divided by h. All right, so we've got some algebra to do. Let's multiply this stuff out. The top becomes 4 over 4h plus 16 minus h plus 4 over 4h plus 16. And now, these two fractions up here, they've got the same denominator. So what I can do is do 4 minus h plus 4. And I got to be careful here. There's this is subtracting the whole thing. So it's not just 4 minus h plus 4. There are parentheses there. Let me rewrite that a little nicer. 4 minus h plus 4 over 4h plus 16. And all of that stuff is divided by h. Instead of keeping that compound fraction, instead of dividing by h, you can just multiply all this by 1 over h. And now nice stuff happens here. Up top, you get 4 minus h and then minus 4. So the 4's cancel and you're just left with negative h. On bottom, you've got 4h plus 16. And then you're multiplying by 1 over h. You can cancel these guys here. And so you're left with negative 1 on top, then 4h plus 16 on the bottom. And that's our final answer. So this one had a lot of algebra to do, but it was after plugging into the same original function, the same original formula for average rate of change. All right, that's it.